Hi, hello! After I show you how to sketch functions and the keys to sketching functions, somebody asked me to show you how to sketch functions using Sine. So let me show you the strategies that I told you in the other video on sketching functions. And the keys to sketch the functions are to identify the main function, to identify the argument of the function to set domain, identify which properties you need to find x and y intercepts, and follow the step-by-step process until you master it. Okay, so I'm going to apply these steps to sketch 3 sine of 5x minus pi 9. Identify the main function. So the first is to identify the main function. The main function here is sine of x. Okay, so keep in your mind what is sine of x. You don't remember? Here is sine of x. Okay, sine of x. Now, then you set the domain. Use the argument to set the domain. The domain of sine of x is from negative infinity to positive infinity with no asymptotes at all. So as we don't have asymptotes, the domain will be the same as the main function, negative infinity to positive infinity. The range of sine of x is from negative 1 to positive 1. But here we're multiplying by 3, so obviously y will be changed as negative 3 to positive 3. Now set the asymptotes of period it has. The asymptotes, sine of x does not have asymptotes. So as we don't have asymptotes for sine of x, we don't need to determine any asymptote. We need to determine the period. Remember that to determine the period, you just need to take the frequency, angular frequency, and the period is 2 pi divided the angular frequency. So the angular frequency is 5, 2 pi divided 5 is the period. Okay, this is the period of the function. Set the y-intercept, x equals 0. You just need to determine 3 times sine of negative pi 9. We'll see in a moment how much is that number. And set the x-intercepts is just by using 0 equals 3 sine of 5x minus pi 9. Okay, setting the equation equals to 0. 3 sine of 5x minus pi 9. Here is pi 9. Okay, 0 divided 3 is 3, no problem. And now you have 5x minus pi 9. So what you have to do now, what we have to do, we need to determine how this argument is changing according to the intercepts. That's why you need the main function. The intercepts of sine of x are n minus 1 times pi. Okay, n minus 1 times pi are the intercepts of sine of x. But we need to use the domain or the properties you need. Which are the properties you need? The properties you need is the inverse of sine. The inverse of sine is n minus 1 times pi. So the argument is equals to n minus 1 times pi. So the argument is equals to n minus 1 n minus 1 times pi. Okay, and here we just have to solve the equation for the number. Some students have really problems to solve this type of equations because of the fraction. So just read off the fraction and that's okay. So let's multiply by 9 everything. Times 9, 45x. Pi 9 times 9 is pi. And here we just have to multiply by 9. Okay, now we're going to add by pi. Let's add by pi plus pi plus pi. And if I simplify, we're having 9n minus 9 plus pi. So pi is a common factor. Attention, you're not adding here pi plus pi because pi is multiplying. So it's a common factor. So negative 9 plus 9 plus 1 is 8. Okay? And finally divide by 45. Divide by 49. By 45. So divided 45, and here we have the options. So let's find the first x-intercept. The first 3 x-intercepts. X sub 1. X sub 1. So n equals 1. 9 minus 8, 1. 1 divided 45, pi. So pi 45ths. Pi divided 45, or pi 45ths. So let's determine now x sub 2. X sub 2 equals 9 times 2, 18. 18 minus 8, 10. 10 divided 45, pi. So 10 pi 45ths. Okay, now I'm gonna leave this expression because I'm gonna use it. Later, but it's better to simplify the answer. Okay, always simplify the answer. So we can have the fifth part, 2 pi ninths. 2 pi ninths. Okay, and the third intercept is for n equals 3. 9 times 3, 27, minus 8, 19. So we have 19 pi divided 45, or 19 pi 45ths. And that's it. So we have the first 3 intercepts. Something you can do to check whether your answer is right or not is to subtract the third intercept and the first intercept. Okay, because the third intercept and the first intercept should get the period. Okay, the first intercept, second intercept, third intercept. If I subtract the third intercept and the first intercept, I should have the period. So let's see if it works. 19 divided 19 minus 1 is 18. 18 pi divided 45. 18 pi divided 45. I can get the 9 part, 2 pi fifths. Okay, you can do it step by step to see the process, but the thing is that we have the period here. So we have the intercepts now. So you just set domain, set the range, set the asymptote or period, set the y-intercept, and set the x-intercept. So we're going to determine the function. I have here the y-intercept. Use a calculator to determine, and I have here the x-intercepts. So I need to change it. It's not 11, is okay, a mistake. So we're going to set a point, and the point is going to be, so pi divided 45. Oh my god. So pi divided 45 and 0. Okay, and the second point is the second point is 10 or 2 pi ninths, and the third point is 19 divided 45. 1945. Okay, there's something weird here. Pi divided 45. I wrote 29, sorry. It's 2 ninths. Okay, now that's it. So now we just have the points here, and we have the points, and we have to do the graph. If you have graph paper and you want to do the exercise appropriately, just set the expressions using squares as terms of 45ths. Okay, so for example, set 1 square to tell that 1 square is going to be 10 45ths of pi, or to tell that 1 square is going to be 2 45ths of pi. Okay, such as when you do the graph in your graph paper, you're not having this type of situation that I had, that is really complicated here in a program. So you in a graph paper is going to be easier. Okay, it's going to be easier. Now you just have to do the graph, and we know that the domain is 3 and negative 3. So let me do a line that tells me y equals 3, and a line that tells me y equals negative 3. Okay, I don't need f. And we're going to do the sketch. In between the x-intercepts, you should have the highest and the least value. So let's try to do the sine. Okay, done. Okay, this is my sketching. Obviously you can do it better than this line, but I'm using my computer. Okay, but now we're going to see if the answer is right. This is the function. We're going to see if it's right. Perfect, look at, pass it by the point, and this is the period. Okay, this is how you can sketch a sine function. I know that this is going to be pretty long sometimes, but this is the way you can sketch a function, and this is the way you can check the options. For example, if you have secant, take into account that in secant we have asymptotes in the domain. So to determine the domain, you need to find asymptotes first. And remember that secant does not have x-intercept because secant is the reciprocal of sine. So we don't have x-intercepts. You don't have to find x-intercepts, you need to find asymptotes and determine the main function. Thanks for watching, and see you in another time. I hope that you understand, and remember the 4 steps: domain, range, intercepts, asymptotes, or periods. And remember the 4 keys. Follow the steps, and following the steps, identify which properties. Here we apply the properties of sine. Identify the argument of a function. The argument was 5x minus pi ninths. And to identify the main function, that is sine. Thanks for watching. See you next time. Goodbye.